Hello students, today we are discussing Biot-Savart law. So actually Biot-Savart, these two are the two different scientists. Okay, so Biot-Savart, both of them different scientists. So actually this Biot-Savart law explains about electrical, okay, electrical and magnetism, okay, magnetic property of a charge, otherwise current carrying conductor, current carrying conductor. So here we can say, here actually when current is passing through a conductor, current passing means what? Charges are moved inside the cross section of a conductor. So here the magnetic field produced by this, what is the magnetic field produced by it? So magnetic field is what? For example, just you can take it as like is any shape, we can take it as a straight wire or any different forms also. Okay, so if the current is passing through this here, this, and next one, from this we have to choose a length element. From this one is the any one, it's what current direction is what? I. Here is the length element. Just to imagine, it's a length element. Okay, length element is what? DL. DL is a length element. DL direction is direction of current. Okay, so I want to know that what is the direction of this DL? Direction of DL, what, like this one, and if you want to find the field at this point, let it be this. Okay, so is the length element is the direction, and the magnetic field is what? Right hand thumb rule, so is what in the direction of current, and fingers are into the plane. So this I can write it as a cross. Okay, so now here the line joining from here to this, which one is this? Length element is DL, and the point P where you want to find the magnetic field, say, so this is R, and the angle between the direction of length element and a line joining from the length element to the point where you want to find the field is, let it be theta. Okay, is just explanation about like a Biot-Savart law. So has given the relation with the magnetic field at this position, the relation with the length element, and so it's a sine angle between these two. Okay, and next one is the current passing through it. So the magnetic field, very first condition is what? dB is proportional to current passing through the conductor. As current increases, so magnetic field at this position increases. And next one, dB is directly proportional to, so it's a length element. Length element is what? Current element also I can say, it's what? It's a length element is a DL. This is the second condition. And magnetic field induction dB is proportional to sine theta. Okay, sine theta is sine angle between the direction of current element, and next one is the point where you want to find the field, so it makes an angle theta. Okay, and next one is dB is inversely proportional to R square, otherwise dB proportional to 1 by R square. So this is the fourth condition. From these conditions, from above relations, we can write dB is proportional to, so I dl sin theta by R square. So if you remove the proportionality, we can write it as dB is equals to the constant. Okay, so it's what you say, mu naught by 4 pi I dl sin theta by R square is the relation of magnetic field. So the magnitude of a magnetic field at this position dB equals to mu naught I dl sin theta by R square. So if you want to write, this is for example mu naught value is what, 4 pi into 10 to the power of minus 7, and next one is it's a 4 pi ideal sin theta. If I substitute this one, I will get a magnitude. The magnitude means what, it's a constant. Okay, so and what is the direction of that magnitude? Show that one, if I want to write the vectorial condition, dB bar is equals to mu naught by 4 pi, so I dl sin theta by r square, it's a r cap. Okay, it shows that direction of this physical quantity. So r cap is what, r cap, otherwise r hat. So it gives, so this is what a unit vector which gives the direction of physical quantity. Okay, so now I am writing this one, dB bar is equals to mu naught by 4 pi I into, okay, so that's what, dl bar cross r cap by r square. A cross B means what, AB sin theta. Okay, so this is dB is equals to mu naught by 4 pi I dl bar cross r cap by r square. So what is the r cap? We know this one. R cap means what, r bar by modulus r bar. It means r. Okay, so this I can write it as dB is equals to mu naught by 4 pi I dl bar cross r bar by what, r cube is the relation. Okay, so this is the magnetic field. So from any given current carrying conductor, so it was given by the Biot Savart. So Biot Savart's condition is what, so dB is equals to mu naught by 4 pi ideal sin theta by r square. Okay, so now just I'm changing a word like so for example, so in this relation I'm writing is this. This is the dB is equals to mu naught by 4 pi I into dl bar cross r bar by what, r cube. So is the vectorial presentation of magnetic field due to current carrying conductor. Okay, so this is one relation. And next one, if a charge is moving, so next condition, what, if a charge, sir, charge means when a straight current carrying conductor means inside the conductor, so the direction of positive charge we consider, direction of positive charge is the direction of the current. Okay, so just individually I am talking about this, a charge is moving. If a charge is moving, charge is with a velocity, okay, a velocity. So the velocity of the charge is, it's a v, let it be. Okay, so just for example, right, this is the velocity, this charge is what, plus q. Okay, so next one, for example, if I want to, if it is moving like this one in the field, okay, so I need to find the magnetic field. So what is the magnetic field? At this position, what is the magnetic field? Okay, so is the direction of this one, this is what, q, it's a plus q, or length element, that's what, charge element also we can say this. Okay, so here we can write, it makes an angle theta. So from this relation I can write this is what is IDL. Okay, IDL. IDL means what, dq by dt L. Okay, so it means what, dq times of L by dt. So it gives what, velocity. This I can write dq to v is the relation. Now I am writing, this is Biot Savart law, means what, magnetic field due to moving charge dB is equals to mu naught by 4 pi. So that's what, IDL means what, dq into, so what is that, v bar cross r bar by r cube is the magnetic field due to moving charge, a velocity v, making angle theta, the direction of velocity. Okay, so this is what the magnetic field. So here, whenever you are talking about this, the charge element means what, a small charge if you consider the dq. So if you want to find the magnetic field, total magnetic field means what? Is equals to integration over of this. Okay. So this is the Biot-Savart law. So we'll see its applications. Next one, magnetic induction at the center of circular coil. Circular coil. Circular current carrying coil. Current carrying coil. So at the center of circular current carrying coil. So for example, if I am taking about this is the circular coil. Okay. So it's what, for example, the current is passing this way. So what is the direction of current? Clockwise direction. Okay. So I want to find the field at this position. So what is the direction of field? To find the direction of field, so right hand, curl finger. So right hand curl finger rule is what? So I am showing this. This is the right hand. Okay. So for the right hand, curl fingers are in the direction of current. Okay. So this is curl fingers are in the direction of current. They are in the direction of current. And next one, thumb indicates magnetic field, direction of magnetic field. So right hand curl finger rule, just you can see this one. This is what right hand, and next one, curl fingers are in the direction of current. So the field is into the plane. Okay, into means what? Already we have discussed it. So means negative z axis. Negative z axis means k cap. Positive z axis means it's a plus k cap. Okay. So now, so let me know about how should I calculate magnetic induction at the center of circular current carrying coil. Okay. So for this, just your duty is what you need to choose about a small element, the length element or current element, anyone you can say this. So it's a DL. Okay. So its direction is what? Its direction is like this. So this is where you want to find. Sir, I want to find at this position. Direction gives what? It's a tangent. So from ear to ear, what is the distance? It's a R. The angle between these two is what? 90 degrees. It's a 90 degrees. So what's our formula now? So dB is equals to mu naught I dl sin theta. Direct I am writing. It's a 4 pi r square. Okay, r is the distance where you want to find it. Okay, so what is the theta? Theta is equals to 90 degrees. Actually, what is theta? Theta is angle between length element. Okay, length element, direction of length element, and next one is what? It's a from a r. So with the r to length element. So this is sin 90. It's what? 1. Okay, so this is what? dB. dB is equals to mu naught by 4 pi. Okay, it's a mu naught by 4 pi I as this. Okay, it's a I, and next one by r square. So this is dl. It's a d. Now I want to find, this is for one small part. Okay, so when you speak about this, it's dividing into the infinite parts. Means smallest part means here infinite terms divided means what? That we take about it. If you want to add infinite terms, so you can go for the integration. Okay, so from this, so I want to write on this b is equals to, it's a b is equals to mu naught by 4 pi, okay, I by r square integration over dl. dl is what? Total. From where? From here to here. Means what is the length? 2 pi r. Okay, circumference 0 to 2 pi r. Okay, so 2 pi r. Here I written small letter r, capital letter r. No issue for this one. Okay, so now b is equals to, we can write mu naught I by 4 pi r square. Integration of dl is L So 0 to 2 by r. Okay. So now we can write on this. E is equals to mu naught I by 4 pi r square. Okay. So it's a by r. It's 2 by r. By 1s are 2 by 2s are. R and r cancel. E is equals to mu naught I by 2 r. So what is the magnetic field induction? What is the magnetic field induction? At the center of circular current carrying coil, E is equals to naught I by 2r. If you write for the n number of turns, see, we can observe next level we will see about solenoid. Okay, so small n and capital N, you must be clear on these two terms. Okay, so small n is what? Number of turns per length. Okay, and next one is what? Capital N is what? Number of turns. Okay, so if you write about for the n number of turns means what? E is equals to mu naught n I by, it's a 2r, mu naught n I by 2r. N is what? Number of turns. So this is number of turns. So what is the magnetic field induction at the center of circular current carrying coil? So it's what? B is equal to mu naught n I by 2r. N is the number of turns, or mu naught I by 2r. So the current is passing like this one. It is into the plane. Into the plane means what? It's a minus k cap.